You know that feeling, right? You're on a website, you click a button, and bam, part of the page just updates instantly. There's no jarring full-page reload. Or you start typing in a search bar and the results just appear right there as you type. How does that incredibly seamless, snappy experience actually happen under the hood? Well, a lot of the time, the magic behind that feeling is a JavaScript library called React. It was literally built to solve this exact problem: how to build complex, super fast user interfaces without all the headaches. And today, we're going to pull back the curtain and see exactly how it does it. Okay, so before we dive into the how, we've really got to understand the why. To get what makes React so special, we first have to look at the problem it was created to solve. Why did we even need something like this in the first place? Here's the big problem it tackles. Messing with the actual structure of a web page, what developers call the DOM, is surprisingly slow. In the old days, changing even one tiny little thing on the page often meant the browser had to redraw the entire thing. It was clunky, it was inefficient, and it made websites feel slow. React was born out of this frustration with one main goal: to update only the absolute minimum necessary and nothing more. So, how does React build these super efficient interfaces? Well, it all comes down to a really smart philosophy: breaking everything down into small, self-contained, manageable pieces. Seriously, the best way to think about it is like building with Lego bricks. And with that Lego analogy in mind, every single React app, from the simplest to the most complex, is built from two fundamental types of bricks: elements and components. Getting the difference between these two is absolutely key to understanding React. Okay, let's use that analogy. An element is your single Lego brick. It's just a simple description, an object that says, hey, I want a button here, or put this text on the screen. It's plain, it's simple, and once you create it, you can't change it. But a component? Now that's where the power is. A component is like the Lego factory, or maybe even better, the instruction manual. It's a reusable chunk of code that you can use over and over again to produce a whole structure of elements. You don't build your app brick by brick. You build it by putting together these powerful, reusable components. All right, so we've got our building blocks. We have our components. But a pile of Lego bricks, no matter how well made, is still just a pile of bricks. It's not that interesting yet. How do we make them come alive? How do we make our app actually do something? And this leads us to the next critical question. A component is great at showing information, but what happens when that information needs to change? A counter needs to go up, a user needs to type into a form, a list of items needs to be updated. How do we handle that? The answer to that is a hugely important concept in React called state. The easiest way to think about state is just memory. It's a component's own private built-in memory. It's any piece of data that's expected to change over time. And here's the cool part. Whenever that state changes, React automatically knows it needs to update the screen to match. So how do we give our components this memory? In modern React, we use these incredibly handy tools called hooks. And the most fundamental one, the one you'll see everywhere, is called useState. That one little line of code you see here, that's basically the magic spell that gives a simple component a brain. Now, don't let the code intimidate you. It's actually pretty straightforward. First, useState 0. That's us telling React, hey, I need a new piece of memory for this component, and please start it with the value of 0. In return, React gives us back two things. The first one, which we're calling count, is the variable that holds the current value. And the second thing, setCount, is a special function. It's the only correct way to update our count variable. When we call setCount with a new number, React takes over and automatically redraws our component on the screen with the new value. It's that simple. Okay, we have components and we have state. We're building interactive UIs, but now we get to the real magic trick, the core innovation that makes React so ridiculously fast and efficient. Let's look under the hood. Remember what we talked about at the very beginning? Touching the actual web page, the real DOM, is the slow part. It's the biggest performance killer. React's creators knew this was the main bottleneck, so they came up with an absolutely brilliant workaround to do it as little as possible. And that workaround is called the virtual DOM. I love the blueprint analogy here because it's perfect. The virtual DOM is a super lightweight copy of the real UI that exists only in the computer's memory. And because it's just a simple JavaScript object, making changes to this blueprint is lightning fast. I mean, way, way faster than messing with the actual page in the browser. So here's how the whole dance works. When you change the state, let's say you click that counter button, React does not immediately go and change the web page. Nope. First, it creates a new virtual DOM, a new blueprint, with that change included. Then comes the genius part. It compares the new blueprint with a snapshot of the old one. This comparison process is called diffing. React is incredibly good at finding the exact differences. It'll say, aha, the only thing that changed is this one number inside this one piece of text. And only then, as the very last step, does it perform a quick, surgical strike on the slow, real DOM, applying only that single minimal change. That's why it feels instantaneous. All right, let's zoom back out and look at the big picture. We've seen the bricks, we've seen the brains, and we've seen the magic. So how does this all come together to build a real application?
So really, at the end of the day, here's your essential React toolkit. You've got components, which are your reusable UI factories. You've got state, which gives those components their memory. And you've got the virtual DOM working tirelessly behind the scenes, that secret engine that makes sure everything just flies.
And that right there is the core philosophy. As a developer using React, your job is to describe what your UI should look like. You do that by building a tree of components. You give them memory where they need it using state, and then you just let go. You trust React to handle the hard part, figuring out the most efficient way to translate your description into a fast, responsive web page. So there you have it. You now have a solid mental model for how React actually works. You get the fundamental building blocks, components, state, and the virtual DOM.